Today, 3D is going to reverse engineer this part using a caliper. The first thing I'm going to do is just look at all the features on the part and start to plan my CAD strategy. If I start to see lots of flat surfaces, I'm thinking extrude bosses. If I see lots of round features, like this over here, then I'm thinking revolve. There's an interesting angular face over here. Here's a bolt circle with 4 countersunk holes. We have a blind hole. That's a hole that doesn't go all the way through to the other side. We're going to have to measure this somehow.
So before we actually reverse engineer this part and produce a CAD model of it, we're going to create a sketch. We're going to draw it up on paper. Just because we don't want to disrupt our CAD process by having to stop all the time and pick up our measuring tool and pick up our part and then come back to our mouse and back and forth. It can really slow your process down. So first I'm going to create a sketch. And you might have noticed the language that I was using to describe the part. Things like saying there's like arcs here and bolt circles, blind holes. What I'm doing is I'm already getting into the process of how my design intent will flow. What? I'm getting into the process of how I will design the part in CAD. So how I'm going to build my feature tree, what types of features I'm going to use. Anyway, I'm going to start with a top sketch. I'm just going to trace it out. You know, if this is not an option for you, maybe just draw it by hand. It's not arts and crafts class, so just going to get it kind of close enough. Sure. Circle here, 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 here. And then it kind of looks like there's one of these things. One of those. Right, 1, 2, 3, and then this one has a hole here. Whoops, I already screwed this up. That's okay. Fix it. So it should be, there's like a flat thing over here too, right? This is that angled face. And then if we rotate this for our third angle projection, this side would look kind of like, well, I guess in this case I can do that, right? Ah, that's pretty bad, but it's okay. And then we know that hidden lines look like this, right? So we could draw those hidden features there. Wait, so this is like what again? Like this, and then we did that. So there'd be a couple other hidden lines that go across like this. Not super important to do all that, right? The important thing that we're trying to do, oh, and then there's that blind hole that comes down like this. Oh, there should be little countersinks there. Yeah, that's good enough. Now, I did that tracing method because I figured this would be big enough for me to leave all my dimensions in, but if that doesn't work out for you, you might have to scale your drawing up so that you can get all the features. The caliper can measure in a few different ways. The most typical one is the outside measure, right? Okay, so there we got 9.94 millimeters. Before you start reverse engineering, or somewhere in the process, it might be a good idea to figure out, did the previous designer design this part in imperial units or metric units? Maybe take a quick couple measurements and see what makes sense. 1.2. Just given that first reading, I'm gonna assume that this was made in metric units. Okay, so that's 9.5 over here on this diameter. Here's my extension line. This might get messy here in my drawing. But I'm not gonna write down 9.5. I'm just gonna call that 10. Because again, we're reverse engineering. We're not trying to replicate exactly this. We're trying to replicate what this is supposed to be. So in this 3D printing process, maybe there were some dimensional inaccuracies. Okay, from here to here, I'm gonna call that 22.5. And what about this one, from here to here? last step I'll call that 30.5, and the total width, we'll call that 40.5. Kind of ran out of room. I'm just going to draw it like this. Now I'm not necessarily following any drafting standards. I'm just trying to quickly get this out, right? What about the diameter of the holes? Now this brings us to our second method of measurement. We can use these jaws over here. Now you notice these open the opposite way. These are inside measuring jaws. So we can put them in a hole and open them out and get a measure. I'm going to measure a couple just to make sure that I don't get a hole that happens to be bad. So it looks like 3.25. 3. Now, when you reverse engineer, you got to make tough calls sometimes. What's this supposed to be? I'm going to go with 3. Through all. Okay, did I get all of them? How do we figure out this diameter? Can we measure like this? This is kind of tough. Not really. And this is something that'll happen, right? A caliper is not, it's a very versatile tool, but it's not the end-all be-all. There are other types of measuring tools out there. More on that later. Okay, maybe now I'll start to measure some of these depth measurements. What about this one? Here I'm using this back face, you see? So this measures the distance from here to there, from this edge, or from this face to this face. So that would be 0. That would be something else. This is a step measuring feature. Very useful. There we go. This step here looks like it's 10. Now if we were to look at this from the side, right, we see that there's some angle here, right? Looks kind of like this. Oh, I lost count. Shoot, something like that. Wait, 1, 2. Oh, I screwed that up. It's 2. Whatever. I was just trying to show this angle here. Now, what is that angle? Kind of hard to measure angles with a caliper. They're good at measuring straight lines. But maybe there's another way we could figure that out. Let's see, what if we measure this? Now you'll notice I'm holding the caliper, and this is a pretty awkward measure, but I'm holding it kind of flat, as opposed to like this, because then it's hard to know if I'm getting it straight on. But if I hold like this, I can get tangent C on this one side, and then I can ensure that it's flat with the jaws on the other. I'll call that 35 from here to here. And maybe I can measure this. Not ideal. We'll call that 10. Wait, didn't we already have that? Oh no, it's 10 this way. Oh! What about the diameter of this hole? Well, use those inside jaws again. That looks like 4.5. Often I'll measure holes on 2 perpendicular measures. So this looks like a hole with diameter 10. But what about the depth? This is that blind hole. That's a symbol for depth, by the way. Well, we can't use these jaws or even the step to measure depth. But the fourth way of measuring with a caliper, was I calling this a micrometer? This is a caliper. Fourth way of measuring is using this at the back here. See how that comes out? And we can measure depth like this. Watch. Boom. Now the key here is making sure that when you take this measure, you're sitting square and flush and flat at the bottom. So let's see what we get here. Okay, there. What was happening was this edge here was getting caught on some of the layer lines. So because what I'm trying to do is I'm trying to run this cylinder down the side of the part, right? But yeah, you can see how it's kind of getting stuck. Anyway, take the measure. And reason, if I run it down the side of the part, then I know it's, let me just draw it out. So here's our hole. If I run the cylinder down this side wall, then I know that it's square on the side wall. What I don't want is the cylinder to be like this, right? At some angle and a gap there. I'm trying to be parallel with the walls. So here we go, let's take this measurement. Oh, I didn't like that. Okay. 20. Let's do another one. So often it's a good idea to take blind measurements to make sure that you're not impacting the reading. Okay. There. And you want to make sure that these jaws also stay flush. I got the exact same number. So we'll call this a depth of, oops, 20.5. Now, do we have all the dimensions we need? Oh, the bolt circle. What about, what's the, there's a countersink on this one. Now this is a little tough, because how do we measure it? Like this? I mean, not ideal. So how do we know if we're at the right edge? You could also try doing something like this, and making sure the point is right on the edge, and then moving the other one until that's on the edge. Something like that. 6. Let's try it again. Again, not the ideal way of doing it, but we're trying the best we can here. Nope, that's not right. 6.8. So I gotta be careful. One of the mistakes I made when just doing this sketch was when I drew this circle, it kind of looks like it's lower than these holes. It looks like it's down here, but it's actually not. It's in a straight line across, so the circle should be up here somewhere. That wasn't, I gotta be careful I don't transfer that error across. Here's a question. What's the diameter of the bolt circle? Here's another thing we could do with these calipers, is we can measure center points, but indirectly. So watch this. We can measure the hole. And we can see that if we measure it like this, wait, let me draw this up real quick. So we have one hole here, and we have one hole here. We want to figure out what the center of the, where this point is. So if we do an outside measure with these jaws, we're measuring from here to here, right? So what's that? Let's see. That looks like 37.5. From, let's say, here to here is 37.5. Now what we can do, well, some of you probably figured it out. Maybe you can just measure the diameter, take half of that as the radius, and then add that on each side or something. But there's a quicker way we can do it. Well, I think it's quicker. You could do it any way you want, really. We can measure using the inside jaws, and that's going to tell us the distance from here to here. Let me draw some little arrows. There's a lot of squiggly lines and stuff, I know. Right? So this, what is it? 43. The reason I'm so generous with the roundings is because it's a 3D printed part, right? Everything's going to be plus or minus like half a millimeter. Well, now, if we take the average of these two, we can figure out what that whole center is, right? 43.5 plus 37.5 over 2. 81 divided by 2, 40.5. Okay, so this is the diameter of our bolt circle. Oh wait, and that makes sense. We got the same value here and here. But I find I always miss something. But that's okay. Try to get as much as you can. Because this is not our engineering drawing here, right? We're just doing a sketch to help our CAD process.
Alright, so now we're here in SolidWorks, and these round features are calling out to me, and they're saying revolve. Whenever we start revolve, I like to start with a center line. I'll come around and dimension it. Now here's a trick. The measures we took were measures of diameter. So I don't want to define that. I want to define the diameter. So because I have that center line clicked, I can measure from the outside edge through the center line by selecting both the center line and that outside edge, and I can get my dimensions in 40.5. Now, again, this is the key as to why we do a sketch first, because now at this point it's quick work to enter in all these values versus having to stop and measure, and you're picking up and putting down tools. And just in terms of efficiency, you don't want to, uh-oh, wait, what's happening here? I screwed it up already. 30.5, 22.5, oh, there's one more. And like that, right? Cool, sketch is fully defined. We can do our revolve. Excellent. But we noticed the feature, it wasn't just a circular revolve, it kind of came out flat, right? Oh, wait a second. Maybe it's better to do this as a 180-degree revolve, because now I can use this plane to make a new sketch with converted entities that I can then extrude. Okay, it looks like 15. I'm gonna work on the bolt circle next. Maybe I'll go back to this plane. Oh, right, remember it was in line with that. So now the question is, do I want to do a circular sketch pattern, or do I want to save this for a circular feature pattern? You know what? Because I have to do the holes still, I'm gonna leave this as is, do my extrude. It's not gonna be a blind extrude, it's gonna be extrude up to a surface, and this is the surface I want it to go to. Oh, oh shoot, that's direction. This is the face I want it to go to. There we go. Mistake I made, I had this selected. So you can have an extrude. Typically they'll go normal to the surface, so perpendicular to the sketch plane. But you may want an extrude that goes off at some angle, right? So in order to do that, you can draw a line or pick some edge. I was looking for an edge that wasn't straight, but all my edges are straight now, so I can't really demonstrate that. That's okay, this is what I want. One of these. So now you might think, oh, I'll put, I'll just do it. You might think I'm going to do the circular feature pattern now, but this is actually not ideal. I'll show you why by doing it incorrectly. So first step is pick an axis. Now, you don't have to pick an axis. You can pick a, any round face or a round edge. We're going to need 4 of these. Oh, and it's not 360, it's 180. There we go. See how I did that? That flips the direction. Okay, now here's the problem. If you do your circular feature or your linear feature pattern too early, you kind of lose out on a lot of the power, because now I still have to go and make those holes in here. You know what? Because it's countersunk, maybe I'll use Hole Wizard. Throw in some custom dimensions. So we know the inner diameter is 3 millimeters. Because of the sketchy way that I measured it, I'm going to go with the standard values. So I'm going to use 6.3. And yes, it's through all. Perfect. Where do we want it? Well, here. Perfect, right? Except, I don't know if that's actually centered. So we could fix that by turning on the sketch where I drew the circle. When I say turn it on, I mean make it visible. Because by making it visible, I'm now able to select that point in the sketch. If I come back to my Hole Wizard and find the sketch where I made that point, I can edit that sketch. There we go. And make these 2 points coincident. So now it's defined and it's in the center. But you see the problem? The Hole Wizard didn't copy over 4 times? Ah, because in the tree, it comes after the circular feature pattern. So what I can do is I can rearrange this, or I could have just done it in the correct order to begin with, and include the new feature with the circular feature pattern. Like that, right? Now, you might think, oh, well, what about those 4mm fillets? Well, not exactly. Hey, did you see how I did that? 4. A tool to help you select multiple fillets rather than doing it in the sketches. You can have your fillets as a feature, and then if you have this show selection toolbar checked, when you click an edge, this little menu will pop up, and SOLIDWORKS will kind of try to figure out the different, and there's a whole bunch of different options here. It'll figure out the best option to get all the edges you want. I don't actually want that last edge that I clicked though. Oh no. Okay, I'll just delete it here. What? You might have thought, wouldn't it be better to do this and put the fillets in here and then linear pattern the fillets, or sorry, circular pattern the fillets. But circular and these feature patterns tend to have a hard time. Let's see if it works. Fillet. I did say make these 2 fillets, didn't I? But look what's happening. It's only doing it on the one side for some reason. So the feature patterns, like this circular feature pattern, tends to have a hard time making fillets or chamfers on edges that don't yet exist. Meaning, I'm trying to tell the software, create this fillet and this fillet. Some are over here on this feature that doesn't yet exist. So, general good practice to leave your fillets and chamfers and that type of thing for the end. Whoops. There, that's fixed. Also leave your circular patterns for the end, but not before your fillets. All right. So with that in mind, maybe I'll undo these for now, just in case. Sorry, I'm getting all confused which fillet was what because I was trying to do something. All right, well, I'll just do it again. 1, and then I'll just deselect the edges that I don't want to fillet. Okay, something like that, right? So I'm going to need to do this blind hole now, which should be pretty easy. You could do Hole Wizard, but I'm just, oh, wait a second. If you use Hole Wizard will assume that you're drilling the hole with a drill that has a 118-degree point angle, but this part, if we look closely, it's got a blind hole that has a flat bottom, so I'm just going to do it as a sketch. Last thing is to add that angular face. So to do that, I'm going to make a sketch on the right plane. So I'm not sure if it's from this point, but I'll measure that in a second. I was trying to convert entities, but it was too many edges or something. 35. And from here to here was 10. Okay, there. Then I'll extrude cut this through all both sides. That's it. Did we get everything?